is stiffness, irregularity or soft story. We say that stiffness, irregularity or soft story exist when lateral stiffness is then big. So if you look at this figure here, you have a floor where your height is more and other floors are lesser in height. This means that the length is, which also means less. Here you have could be also something like a still floor in the lower floor and walls in the upper levels. Here we have floating columns as well. Here there is an intermediate story where you have larger length, lesser stiffness. So all this creates stiffness, irregularity or soft story in your building. So there are conditions here. So this represents the irregularity. So the solution is structural plan density of masonry shall be estimated. If SDP exceeds 20%, effect of masonry shall be modeled as per clause 7.9. So if the effect of masonry is seen to be more, then we have to ensure that the masonry walls are modeled as per clause 7.9, 1993-2016. Design forces shall be the maximum of bare frame and the model with masonry infill. You have to model both bare frame without masonry infill and with masonry infill, and the maximum forces should be taken. In the story drift, that is the drift difference between floors, shall be limited to 0.2% in the story with stiff and in all stories below. It's like the stiffness cannot be so different that it produces a lot of drift variation between adjacent floors. We have to ensure the drift. Drift means deflection difference between adjacent floors. Another vertical irregularity is irregularity. When it is said to be existing, when seismic weight as per clause 7.7 of any floor is more than 150% of floor. So this generally happens when you have larger weight in one floor and smaller weight in other floors. So things like a water tank at the top or service floor at the top, swimming pools and every heavy equipment, chillers, AC chillers thing at the top, or sometimes you may have also some functional differences. Say you have very floor here, intermediate and all lighter weight floors in between. So if you have such a case, call it mass irregularity. So the solution: in buildings with mass irregularity and located in zone 3, 4 and 5, dynamic analysis needs to be performed. Now there is another vertical irregularity. This is geometric irregularity, which we might have already seen in the last module. So here you have offsets in your height, here you have offset in your height. So separation joints can be used in this kind of irregularity. Here it may not be possible because it's cantilevering structure as you go above. So that solution may not be applicable. So here in zone 3, 4 and 5, dynamic analysis needs to be performed. This is as per clause 7.7. Please note that lateral resisting system in any is less than the horizontal dimension by 125% of the floor below. Then you call it vertically irregular. In plane discontinuity in vertical elements. Sometimes your columns or shear walls shift in elevation like this. You can see here. So is shifting the location in plan. So in elevation it is very clear there is a shift of shear wall. So if you have such a case, that is when in plane offset of vertical elements is greater than 20% of plan length of those ends. In that case, in zone 2, the lateral drift shall be limited to 0.2% of building height. The total lateral drift can be more than 0.2% of building height in any floor. In zone 3, 4 and 5, in plane discontinuity is not permitted. So this is not allowed in zone 3, 4 and 5. Here it is weak story or strength irregularity. So when it is said to be existing, when lateral strength of story is less than the story above. It's like you have a very weak legs and a very strong body. So this is generally existing when you have a lower floor which is higher in dimension, the height is more, or when you have an open stilt with no masonry or no shear wall in the lower floor, and upper floors are all having masonry infills. You have intermediate floor with larger height and things like that. And the solution is, in zone 3, 4 and 5, buildings shall be designed so that safety of building is not jeopardized. Also, clause 7.10 be followed. All irregularities try to be avoided. So that is how you need to attend this weak story problem. Now another irregularity is floating columns. Such columns created concentrated damages in your structure. The chances of disproportionate collapse, everything will be very high. See, you have a column which is planted on this beam, so this is like a transfer beam, and then when you have a very heavy load coming here, it can create concentrated damages. So it should be preferably avoided, and it is prohibited if it is part of or supporting primary lateral resisting members. So the floating shall not support any of the primary lateral resisting members. It can be a gravity element in your building, but it should not share any of the lateral loads. So you have to do your analysis in a way that the lateral loads aren't transferred to the floating columns. Now the last irregularity is irregular modes of oscillation. When it exists, if the first three modes contributes less than 65% mass participation in each direction, when fundamental natural peaks in two directions are closer by 10% of larger value. Now what do you mean by first three modes? What do you mean by modes? What do you mean by mass participation? These are more elaborately explained in the dynamic analysis module. So please have a look at that module as well. So the solution is, in seismic zone 2 and 3, it shall be ensured that the first three together contributes at least 65% mass participation factor in each principal plan direction. In seismic zone 4 and 5, it shall be ensured that the first three modes together contributes at least 65% mass participation factor in principal plan direction. Fundamental natural period in two principal plane directions are away from each other by 10% of larger value.